Okay, good evening everyone. Please, can you settle down quickly? All right. So this week we'll start arrays and we'll finish also. Uh, so can anyone tell me why do we need arrays? Yeah, to store multiple values, but we can do that anyway using variables, right? Huh? 100 variables, yeah. Right. So silence, please. Okay. All right. So when we have many values, all right, when we have many values to deal with, for instance, like the students in this class, there are too many people to deal with. I can't help it, right? And in case I have to, find out your details, whatever it is, to, fail you or punish you, whatever it is, I need to have the list, right? Now, no one can store that, right? Like in this course alone, there are 620 students, right? So 620 variables doesn't look good. And imagine if some student leaves, some other student joins. Now, what do I do? Do I override one of the variables or I ignore one of the previous variables and add a new variable? Right? There are many issues here. And second thing, I want to keep the order as well. I just don't want to store them in any order we want. Right? Now, if I have to order them, how do I order? I have some 600 different variables. How to order them? Right? Someone joins with, you know, a name starting with a different alphabet. Now I need to insert that student somewhere in between. How do I do that? Right? So there are many things which you can't do easily with individual variables, right? Particularly when your data seems to be like a group. This group has some group characteristics or a set characteristics, right? So characteristics of a list. So when you have a list, you can do many things with that list. You can count the number of elements in that list. You can order the elements in the list. You can sort of split the list. You can copy the list, right? So you can do many things with the list. So a list of elements is quite different from elements stored in some bunch of variables. All right. So we will see many applications you know already. Many things, particularly for sorting and searching, we definitely need arrays. Okay. So let's look at arrays. So first thing, so far we have seen only primitive data types int, char, float, double, right? All these data types which we have seen so far, they are called primitive data types because they can store only one value at a time. You say int x, int num, it can store only one integer at a time. You can say char ch, it will store only one character at a time. Float, double, whatever they will store only one value at a time. Okay, they are primitive. Like this is the most basic. You can't go below this, but you can construct using them some more complex data types. Okay, so arrays are something called derived data types. They are not primitive data types, they are derived data types, which can hold more than one value at a given time. Right? Although they can hold more than one value, all the values should be of the same data type. So when we say a list of numbers, all of them have to be numbers. When we say, excuse me. So again, within numbers, we have to specify, are they all integers or are they real numbers? So we can say an array of integers or array of floats or array of characters or array of double, whatever it is, but it has to be array of a single data type. You can't have an array which is a mixture of integers, floats, double, char. No, you can't have an array like that. So an array is also called homogeneous data type. All the values are of the same type. They should be of the same type. Okay, you don't have an option of mixing them. In case you try to mix them, again it will try to do data conversion. You can try storing a character in an integer array, but it will store it as a number. If there is no number mapping, or you can try storing integer in a character array, it will try to store it as a character. And if there is no integer mapping, no character mapping to any to that particular integer, it will sort of print garbage. right? So it has to be of one data type, but there can be many such values. Okay. So an array is a sequence of elements of a given data type stored in contiguous locations in the RAM. We all know what RAM is. We all know what hard disk is. RAM is primary memory, hard disk is secondary memory, right? But in RAM, there are cells. There is a huge sequence of cells, memory cells. Okay. So what we call as byte, each byte is a cell. Okay. A cell of memory. So every cell of RAM is of size 1 byte. Now, when you store data in the RAM, it is stored in these cells, right? If you are storing characters, it will use only one cell at a time. If you are storing integers, it will use 4 cells, 4 bytes. If you are using float, again, it will use 4 bytes, but the format of storing will be different, right? So depending on the data you want to store, this data will be stored in the RAM and it will be stored in a sequence. Okay. Now, an array, what it does, suppose you are you want to store some 100 characters. Fine, you can declare an array of 100 characters. So it will look for how much memory you need to store 100 characters. Each character is how much? 1 byte. So 100 characters require 100 bytes, right? So you need minimum 100 bytes of empty space in the RAM to store this array. So an array will look for some 100 bytes of continuous empty space in the RAM and it will be stored there. If there is no space of 100 bytes, array cannot be declared. It will say unable to declare or no space, memory full, overflow, whatever it is. Okay. Similarly, if you want to store 100 integers, then how much memory you need? 400 bytes. Each integer is 4 bytes. And if you want to store 100 integers, you will need 400 bytes, right? So you will need 400 bytes of contiguous memory space in the RAM for you to be able to store that array in the RAM. Okay. So when you declare an array, that array is given some space in the RAM and that space has to be contiguous. You see how RAM works. There can be many programs working in the RAM, right? You are opening browser, you are listening to some music, you are typing some code, many things you are doing. Each of them occupies some space in the RAM, right? Because this is live memory usage. It is not like some file lying in the hard disk, which you are not using. When you are using the browser, this browser applications, these tabs, as you open many tabs, your RAM gets full, right? Because all those tabs are being used live, immediately, on the spot. So RAM should have space for that. When you are listening to music, RAM should have space for that. When you are working on some code, RAM should have space for that. So there are different segments of RAM which are allocated for these different applications, right? Now, among all these segments, among all these applications which are occupying space, the way they occupy space need not be linear, right? Suppose initially RAM is empty. Okay. You first used the first 100 bytes of RAM for one application. Then next 250 bytes of RAM for some other application. Then next 1000 bytes of RAM for some other application. Now imagine you close the second application. That space became empty. Now it will not move the third application to the second application space. No, it will remain like that. So there is an intermediate space which is empty. Now, similarly, there will be many intermediate spaces in the RAM which will be empty. So the operating system tries to optimize the space usage. Which application you have, how much space does it need? Where should I allocate this space in the RAM? Okay, so it's a very complex process of how memory is used and apply. The memory is allocated for some application in the RAM. Okay, you will learn that in operating systems course. So now the point is, imagine you want to store a huge array, maybe of 1 MB. 1 MB means almost 1 million bytes. It's like almost 1 million characters, right? So if you want to store such a huge array, it should look for 1 MB space in the RAM. Where is 1 MB contiguous empty space in the RAM? There I will store this array. Okay. Array cannot be split. If there is no contiguous space in the RAM, array will not be declared. So you can't have some first 100 cells of the array here in the RAM, some next 250 cells somewhere else, next 400 cells somewhere else. No, you can't have it like that. all 1 MB or 1 million cells of the array, elements of the array have to be stored in the same space. Okay, that is one thing. So RAM should have contiguous. What is the difference between continuous and contiguous? Continuous means it is like a continuous function which is made up of sort of Euclidean points, where between every 2 points there are infinite points. Contiguous means it is made up of discrete elements, like these chairs are arranged in a contiguous way. You can clearly say where one chair starts, one chair ends, but at the same time you see a sequence of chairs, right? You don't get confused between like where does this chair start, where does this chair end, where does the next chair start. You don't get confused like that. The objects are clear, they are discrete. So when you arrange discrete objects in a row or in sequence, that is called contiguous. When you cannot distinguish between neighboring elements, that is called continuous. Okay, in RAM the cells are discrete. You know what is the address of a cell, what is its size, how many bytes it has, and where does it end, where does the next cell start. So there are many discrete cells arranged one after another. So it is called contiguous. These are called contiguous locations. Fine. Now in this image, you can see some numbers. Okay. So this is the array. So there are some elements in this array, right? Like 11, 9, 17, 89, so on. Now these numbers which you see, this is called index. Like I have to say, no, what is the first element, what is the sixth element, what is the 10th element, something like that I should say. So that indexing is given by these numbers. But if you notice one thing, the index of an array always starts with 0 and not 1. The first element's index is 0, second element's index is 1, third element's index is 2, and 10th element's index will be 9, nth element's index will be n minus 1. Okay, so an array's index runs from 0 to n minus 1. But the total number of elements are n. Fine. And what are these numbers? These numbers are the addresses of these cells in the RAM. So in the RAM, if you ask, okay, where is this array stored? Every element has some address in the RAM. You are able to access an element in the RAM because you know its address. The program does it. You need not worry. Okay, you will understand it better when we get into pointers. But in general, even when you say int x equal to 5, whatever it is. So that variable called 5, that variable called x, the value which it is holding, it should be stored somewhere in the RAM, some location. That location has an address. Okay, so these are all locations in the RAM, and each of these locations has an address. Now, if you notice, there is a pattern. This is 200, 204, 208, and so on. Can you tell me why? 4 bytes. This is an integer array. Each integer occupies 4 bytes. So the address of this integer is 200. After 4 bytes, next integer will start. After 4 bytes, next integer will start. Okay. If it were character array, then this would have been 200, 201, 202, and so on. But since this is an integer array, the addresses are separated by 4 bytes. Okay. So that is how arrays are stored. Fine. So you need to keep in mind, particularly the elements, these are values, and this is index. These addresses or locations, we will again get back to them when we look at pointers. Okay. But currently this is simple. You have an array of integers, and each location has an index. Index starts from 0, ends at n minus 1. This is something which you need to keep in mind. Okay, now how do we define arrays? Like, suppose I want to declare an array of 4 integers. Array of integers which has 4 elements. So one way is you declare it like this: int some array name. Here array name is A, and its size 4 elements. It can hold only 4 elements. Okay. And how do you initialize the values? You initialize the values one by one. Okay. First element is 2, second element is 5, third element is -3, fourth element is 1. All right. First element index is 0, so you write A of 0 equal to 2, A of 1 equal to 5, and so on. All right. Now in this, you notice a fundamental difference. In the first line, in the declaration line, we wrote A of 4. Okay. That line is telling you the array name and the size of the array. But later, whenever you use this kind of syntax, again, which is looking very similar to A of 4, this means something entirely different. Here it is not saying array name and size. It is saying array name and the index. Okay, A of 1, A of 2, A of 3, A of 0, they are referring to the index. Which location of the array, which element of the array do you want to access or do you want to initialize? Okay, here, will you get A of 4? No, because there is no index called A of 4. It ends at 3. It goes, like I said, for an array of size n, the index runs from 0 to n minus 1. For an array of size 4, the index runs from 0 to 3. Right? So, don't get confused. When you see this kind of thing, always be clear. Is it referring to the index or is it referring to the size? Okay? Only in the declaration statement, it will refer to the size. In all other cases, it will just refer to the index. You will never get A of 4 except in the declaration statement. Right? In all other cases, you will use indices running from 0 to n minus 1. You will never use the index n. A of n you will not use except in the declaration statement. Okay? This is another way of declaring. You declare it in one line. Okay? You say the data type of the array, the name of the array, the size of the array, and you also initialize the values of the array in the same line. Like this is similar to variable declaration, right? You can either just declare the variable and then initialize it later. What is the difference between declaration and initialization? Declaration means you are just telling the name, announcing the name. Initialization means you are giving it a value. Okay? You can declare and initialize together in the same line, or you can declare in one line and initialize later somewhere in the code. Similarly for arrays, you can either declare and initialize like this in the same line, or you can declare first and initialize the array later. Right now they are shown in consecutive lines, but maybe first you declare the array, later you take the values from the user, and then you initialize those values in the array. Okay? This is another method. Another method is, suppose you know the number of values and you know what those values are. You can put empty brackets here. Okay? It will automatically infer the size. It will populate the array. It will also infer the size. Okay, this array is of size 4. Alright? You can specify the size if you want, or you can leave the size if you want, if you know the exact elements. Now, why do we need to specify the size sometimes? Sometimes my array size may be larger and the number of elements which are available to me may be smaller. Right? In that case, if I declare the array like this, then the array size will be only 4. Suppose I want to store 8 elements. Okay? But if I declare like this, it will create an array only of size 4. I can't store remaining 4 elements. But if I declare here what I will do, I will write int a of 8 equal to these 4 elements. Remaining 4 elements will be by default initialized to 0. I can override them later. Okay? So if my elements which I am initializing and my array size, if they are different, then use this method and use a different number here. If the initial elements which you are declaring or initializing is always the array size, then you need not put any number in the bracket of array name. Okay? Now, this is an example, like I said. I want my array size to be 4, but I know right now only 2 elements. I can declare like this also, it's not an error. What it will do, the remaining 2 elements, it will initialize them to 0 by default. Okay? So that's one way of doing it. This will lead to an error. You either mention the size and leave it there, or if you are giving empty brackets, you have to specify which elements are going into that array. Otherwise, it doesn't know what is the size of the array, how much should I create, what size array should I create, right? Here, when you put empty brackets, it does not know what size array it should create, right? So it will give an error. Fine. If you are giving empty brackets, you have to specify the elements immediately. If you are not specifying the elements, you have to put something in the bracket. You can't give empty brackets. Fine. So this I mentioned just now. While initializing, a of 4 refers to the name and size of the array, but while using later, a of I refers to the ith element of the array, not the size. A of I does not mean array is of size I. No, ith element of array A we are accessing. You can put some value in it, or you can print it, whatever it is, you are accessing that element. Okay, that's how you access elements of array, right? Otherwise, there is no other way for you to access an element of an array. How will you access? You need to give the array's name, and you need to say which element of this array do I want to access. That you say by using a of I. Fine. So only in the first line, in the declaration line, a of n means array name and size. In all other lines, a of some number means that number indexed element of the array, not the size of the array. Okay. For an array of size n, index always starts with 0 and ends with n minus 1. This also I mentioned. We can access the elements using a of 0 to a of n minus 1. You never access any element using a of n. There will be no element with the address a of n. Okay, of size in an array of size n. If you try to access elements greater than n minus 1 index, it might print 0 or some garbage or random value, since it is accessing the memory outside the array. Right? Like I said, array is stored in RAM. In RAM, many other things are happening. Many cells will be there. Some data will be there in each of these cells. Suppose my RAM size is 100. I am declaring an array of size 50. Now, if I try to access locations beyond 50, 51, 52, and so on, already some other program may be using those cells, and it might have already filled some values there. Now, my array, my program is trying to access those values, and it will print the values already existing there. Or that space may not be being used by any program, so it may just have some arbitrary values. So it will just print those values, but they will not make any sense to you because they will seem like garbage values, some random numbers. Okay, I'll just show you in a while. An array can have elements of the same data type only. This I mentioned, it's a homogeneous data type. These are some examples of different types of arrays: int array, char array, float, double, right? Array can hold any kind of data type, but same data type. Okay, fine. So now let's work out some examples. All right. So first, let's declare a normal array, something 5, 20, -8, some large number. Okay. Now I want to print these elements. Fine. So how do I print? I should run through the array. I should go element after element and then print it. How many elements are there? 4 elements. So I should run through 4 elements. So my loop should go from, yeah, there are 2 ways. I can run my loop from 1 to 4, but I need to make sure that I convert this loop iterator to my array index, which means if my I is 1, I print a of 0. If my I is 2, I print a of 1. If my I is 3, I print a of 2. If my I is 4, I print a of 3, which means I print a of I minus 1. That is one way. Another simple thing is I run my I itself from 0 to 3 and I print a of I. That's easier, right? Let's do both the things. Like for int I equal to 1, I less than or equal to 4, I plus plus, printf. Now what should I write? A of I minus 1. If I write a of I, what will happen? It will print a of 1, a of 2, a of 3, a of 4. But for an array of size 4, there is no a of 4. It ends at 3. It starts at 0. So I have to write a of 0 to a of 3, which means I should write a of I minus 1. Okay, so let's see. It printed those values. Fine. Now suppose I write a of I. Let's see what will happen. Which means it will print 20 -8 and that last number and some garbage value. It is trying to access location outside A. See, 20 -8 last number and some garbage value, some random value. Okay, this is not what we want. We want A of 0 to A of 3. Okay, so instead of writing I goes to 1 to 4 and then I print A of I minus 1, this is too much complicated behavior to remember. Simply I will change my loop itself from 0 to 4, 0 to 3. So rather than writing it as I less than or equal to 4 minus 1, because later you use n minus 1, just write I less than n. It will anyway stop at n minus 1. So I equal to 0 to I less than n. Now print A of I. Fine, simple. Now it will print A of 0, 1, 2, 3. Okay, simple. Now the same thing, let me modify by initializing it separately. Now let me take the values from the user. I want to take 4 values. I will take the values from the user. I will store those values in this array and I will print them. Fine. So first I scan. Now what should I write here? Normally if it's a variable, what do? Ampersand variable name. Okay. Now A of 0, A of 1, A of 2, etc. These are like variable names. So I write ampersand A of I. Okay. That's it. It will actually print it. It will read it, print it, read it, print it. Okay. But I don't want it to read and print immediately. I will print later. First, let it read all those. So now fine. First, I am reading all the values, storing it in the array. Now I am going through the array, printing all the values. Fine. So it's waiting for the inputs. I give something, some 83 minus 2, 9. See, it's reading. It read all of them, stored in the array, and now it printed them. Fine. Let me know if you have any doubts. Clear so far? Okay. Okay. Now let us say this. It has only 2 elements. Okay. Some 5 and 8. Now what about the remaining elements? I'll not scan because I just declared them. Right. I'll just print. Fine. It should print 5, 8, and then 0, 0. By default, it initializes the remaining elements to zeros. Okay. So let's test that. Yeah. Fine. If you give less number of elements than the size of the array, it will initialize the remaining values to zeros. Okay. Fine. Now, if I remove this, now what will be the array size? Only 2. I gave only 2 values. Array size will be 2 only. Fine. I didn't declare the size, so it will take the size from the number of elements. Now, if I run this loop from 0 to 4, what will happen? Yeah, some garbage values it will print. It will first print 5 and 8. After that, it will print some random values. Some random values. Okay. So you need to know the size of the array beforehand for you to decide where the loop ends. If you don't know the size of the array, you don't know where to stop the loop. Okay. Usually we know the size of the array. Fine. All right. What else? This is done. All these methods we saw. Fine. Let's just say, let's try the 5th method also, this wrong method. What if we just declare and don't give any values? Okay, let's see. Giving an error. It expects a number or it expects a list of values. One of these or both of these you have to give. Okay, fine. Now, um, now let's do some things. Let's reverse the array, or let's print the elements of the array in reverse. Okay. What should I do? Suppose I say this equal to some 4 elements. All right. Now what should I do? I just reverse the order of traversing the array. Instead of traversing from left to right, I traverse from right to left. Okay. So I equal to 4 or 3? 3. I greater than or equal to 0. I minus minus. Okay. That's it. Now it will print -1, 10, 8, 4. Something I missed. Semicolon here. That's it. Okay, you can do many things later. You will look at sorting an array, right? Merging two arrays, many things you will see. You can also see count number of times an element occurred in an array, or searching for an element in an array. Where does this element occur? What is its location? Like you created an array. Now I want to see whether some element 100 is there in your array or not. Some element 5 is there in your array or not. Now you need to traverse the entire array and see whether each element is equal to 5 or not. If it is, then give me the address of that element. That is one example. Or you can remove duplicates from an array, right? So there are many use cases for arrays. Okay, fine. So this arrays is clear. Integers. Now you create any array you want, float, double, char, etc. Now we will look at arrays of characters. Okay, what we usually call as strings. So let's get that. Taking too much time. Okay, so yeah, so a string is nothing but an array of characters. The way you treat any array, you should treat a string also like that only. Okay, array of characters is slightly special compared to other arrays, because when you look at other arrays, the sequence of elements don't really form a unit or don't really form a group. But when you look at a sequence of characters, they sort of form a word, they form a string, right? So we deal with strings, we deal with words, right? So string technically is nothing but an array, but strings are used in many use cases, right? You try to count the words in a file, number of words in a file. You try to order the words in a dictionary, right? Or you try to compare two strings against each other, like we do. We try to compare two programs which you write, whether you copied or not, right? We do these things. So we can write these programs. It is not like impossible, okay? In fact, later I'll give one problem for you. Write a program which allows you to compare two programs. That will be an assignment problem. Okay? And then we will use that to compare your programs. Okay. So always enclosed in double quotes. Strings should always be enclosed in double quotes. All right. So these are all examples of strings. Okay. You know, normal English letters, you know, they form a string. But if you put digits or numbers also in double quotes, it will be treated as a string. It will not be treated as an integer or a number. All right. And if you put a single character, you can put a single character in single quotes or double quotes. If you put it in double quotes, it will be treated as a string. If you put it in single quotes, it will be treated as a character. You can put a single character in single quotes or double quotes, but you can't put a string in single quotes. String should always be in double quotes. Yeah, silence please. String should always be in double quotes. Character can be in single quotes or double quotes, but if it's in double quotes, it becomes a string. Okay, that's the difference. Anything not enclosed in double quotes is not a string. Character, it's a character. A is put in single quotes, it's a character, not a string. This hello, this word, if you put in single quotes, it will lead to compiler error. If you don't put it in any quotes, it will be an integer. If you try to put it in single quotes, that will also lead to an error. If you put it in double quotes, it becomes a string. And again, no quotes, it is a number. All right. So usually students get confused when they deal with strings which have digits in them. Okay. Be careful whether those digits are inside quotes or not. Fine. But this is while writing the program. When you are giving an input, you don't put double quotes. When you are giving an input through the terminal, you don't put any quotes. If you put a quote, that will also be taken as a character. Okay. But if you are writing a program, in the program, for you to differentiate between a number and a string of digits, you have to put double quotes. Okay. So this is all within the program. Okay. The last character of a string, which is invisible to us, is always a null character. Okay. Now in strings, unlike integer arrays, if you are declaring, an array of characters, if you want to group them and give the entire word at once to you, it should know where that array of characters is ending. Suppose I declare an array of size 50. Simple program. I want to read an input from the user. I want to read a word from the user, and I just want to print that word. Now users can print a word of any size. The only condition is, say, it has maximum 50 characters. Fine. So user can enter a word of 5 characters, 10 characters, 20 characters, 9 characters, whatever it is. It just doesn't cross 50. Now I can't give a fixed size saying all words should be of length 9 or length 10 or length 20. I won't say that. Okay. Now then how will I know what is the length of each word? Because I should run the loop only from 0 to that point. If it is a word of length 5, I will run the loop from 0 to 5. Actually, it's not 5, it will be 6. I'll tell you later why. Sorry. Usually we run it from 0 to 4, right? If it is a word of length 5, we run it from 0 to 4. But in the case of strings, we run it from 0 to 5. I'll tell you later why. Or if it is a word of length 22, I will run the loop from 0 to 22. Okay? I will not run the loop to a fixed number in the case of strings. So there should be a marker which tells me where the word ends. What is the length of the word? Okay? So that marker is called null character. If you look at the ASCII table, this null character's ASCII value is 0. So the first most ASCII value is for this character called null character. You can't see it. You can't print it. It is invisible. Fine. But you specify, it's like new line. You can't see it, right? But you can use it. Similarly, this character, you can't see it, but you can use it. So \0 means ending of a string. Okay. So null character is represented using this, or you can sort of give ASCII value 0. Both are fine. Okay. Hence, the string length should always be n+1, where n refers to the number of visible characters. So if my word has 5 letters, I should declare a character array of size 6, so that the 6th character is reserved for this null character. 5 letters are visible characters, 6th letter is invisible character. So if I want to store n characters, I should declare a character array of size n+1, so that the last character is null character. Okay. So this is something which you should always keep in mind. Again, there are various methods of initializing a string. Now you see, this is slightly easier. If you are using previous method, you do something like this. You declare the data type, character, array name, size, and then you declare each element separately. Each character, okay, H, E, L, L, O, and then finally null character. Right? This is one way of doing it, but this is too cumbersome. You can just put double quotes and write the word. Now, when you put double quotes, don't put the null character. It will automatically insert it. But when you are giving single characters, you have to put null character. Like in this method also, when you are declaring like this, you have to give individual characters, and you also have to make sure that the last element is null character. Okay? Otherwise, when you are trying to retrieve this word from the array, it doesn't know where to stop. It will either give an error or it will give much larger data. It will give HELLO and then followed by something until it sees a null character. Somewhere in the RAM, if there is a null character, it will keep going up to that point. Okay? So, simple. This is slightly different from regular integer float declarations or initializations. If you are declaring a string, either you use double quotes and put your word there, or if you are declaring element by element, character by character, you ensure that the last character is a null character. That is \0. When you are using character by character, you are giving character by character values, always put them in single quotes. If you don't put them in single quotes, what will it do? It will, can you tell me what will it do if I don't put them in single quotes? It will treat it as a string. Suppose this thing, suppose here a of 0 is h in single quotes. Suppose I remove this single quotes and I just give h. What will happen? Yeah, it will take the ASCII value of h. Okay, and it will sort of wait. It will, but right now it will take the ASCII value of h when you put it in single quotes. Okay, so right. So what happens? I think we can test it. It will convert h to its corresponding integer, and it will try to take the first digit of that integer as a character. That is what I am thinking. Even I never tried that. You can try it. Okay, but point is you should give it in single quotes for it to take that character. Okay. So you notice that we are putting single quotes around a character and double quotes around a string. All right. This difference is very important. So let's test it. What else? Yeah, these more methods. So you can also declare a larger size array and give a smaller word. It will sort of end that. So in this example, first 5 characters are hello. So the 6th character will be null character. After that, what is there, it doesn't matter. Because it will, when you try to read it, you can read it as a string or a word using %s. Okay. So it will look for null character. After the null character, even if the array has some empty spaces, it will ignore it. Okay. So after that, we don't know what the values are. They can be random values. Fine. And again, same thing, you can give character by character. Array size can be larger than the number of characters you want to deal with. Now, this 7th method is wrong. This you may do in other programming languages, but not C. You can't directly say, okay, this is the array name. Now this array string value is this. No, you can't do that. Okay. While declaring the array itself, you can initialize it. But if you want to initialize it separately from declaration, then you have to use one of the previous methods. You have to give character by character. All right. Later, you can't say array name equal to string. No. While declaring, you can say array name size equal to string. Fine. But not later. If you want to do that, you have to use a string function called strcopy, the array name and the string you want to copy into the array. This is how this thing can be done. You can't use this statement, but whatever you want to do using this statement, that can be done using this statement. Okay. So you have to use string functions. We will look at some string functions also to deal with strings in C. It will not be, like other programming languages where you can equate two arrays or assign an array directly into, assign a string directly into an array. No, it can't be like that. So there is some specific syntax. You need to understand that. You need to sort of erase what you know in Python, etc. when you deal with strings. Okay, so this is slightly different. You can't concatenate two strings just by doing a plus. No, you have to use string functions for most of the operations. Just for reading or printing and reading, simple percentages, scanf, that will be fine. But if you want to do later some other operations on strings, we will see. We will look at some string functions. Okay. So yeah. So first let's look at simple examples. Then we will try these slightly different examples. So let's say you see hello has only 5 letters, but I am declaring an array of size 6. All right, because 6th character is null character. Now, simple thing, if I want to print that, all I need to do is printf percentage s a. Now, here it will not be a of I or ampersand a of I. It will just be the name of the array. You will understand this when we get into pointers. Okay, it will not be ampersand because you're not giving a particular element's location, a of 0, a of 1, you're not giving that. Why are you not giving that? Why are you giving the entire array name? Because entire array we are reading at once. All right, this is the address. The array name gives you the address of the first element of the array. Now, since the array name itself indicates the address of an element, you again need not give ampersand. You will understand this when we look at pointers, addresses, and so on. Okay, simple. Let's remove this. Yeah. I'm sorry, for print we need not give ampersand anyway. In scanf, I'm telling so far about scanf, not print. I thought I was doing scanf thing. Okay. In printf also you need not give ampersand anyway. In scanf, for strings or character arrays, when you are using percentages, don't give ampersand. If you are reading character by character, then you need to store it in a of I, then you give ampersand a of I. Okay, fine. So that's it. It stored it in array A, it printed it. Fine. Now let's give the size as 5. Let's see what will happen, which means now there is no space to store the null character. First, let's give 4. It is warning, right? Saying the array size is too small. Okay, in this case, it is storing. So basically, it is compiler dependent, but it's not a good practice. It will work sometimes, it will not work sometimes. Sometimes if space is there, if the next space is empty, it will just store null character there. Okay, but if the next space is not empty, it will not store null character there. So better always give extra size for null character. Let's see what will happen if we give 5. I think it will print the entire word like it did for 4. It will print the entire word. That's fine, but that's not a good practice. Fine. Now suppose I try to print it using a for loop. For int I equal to 0. Now, actually, let me first print the normal case. Okay, of 6 I say. Now, what I need to do is, I need to check. You go up to until you find the null character. Okay, so until a of I not equal to null character, increment I. Okay, now print character by character. What should I write? Percentage C. I am running in a loop. So percentage C, no spaces, so that you will see the string. Okay, a of I. Fine. Let's see. It printed. I didn't print new line, so it printed in the same line. Fine. Now let us see. Suppose here instead of 6, I give 4. Okay. Now let us see whether this loop will stop or not. is warning, it is stopping. So basically it is using the next place for null character. That is fine, but every time it may not work. That's not a good coding practice. Okay. Now suppose instead of looking for null character, let me just print next 10 characters. So until I less than or equal to 10, less than 10. Okay. Now let us see what it will do. Some random values, and since we are trying to print them like characters, it is actually reading some number, but that number doesn't have any corresponding ASCII value. I mean, that number is not the ASCII value of any character. That is a larger number. So that number does not have any corresponding character. So it is printing some unprintable character. Okay. So yeah. Why is not printed? Because I gave char a of 4. If I had given char a of 6, then it will print hello and then some garbage values. Is it waiting for some input? Okay, it's going in an infinite loop, something like that. Stuck. Okay. All right. Let me close this. Okay, so this is fine. And then you declare character by character, whatever it is. If you're declaring character by character, ensure that you have null character at the end. Fine. So if you are reading a string, now let's read a string from the user. I won't give any value here. Okay. Now no ampersand a of I or whatever, just a, the array name. Now I just print the array. Okay. Let me print a new line here. All right. Fine. So something, it printed that. Now what if I give a smaller string? It printed that. What if I give a larger string? So you see, it aborted with an error. Stack smashing is detected. It means it overflowed. All right. So sometimes it all depends on whether space is there in the RAM or not, which you have absolutely no clue of. Okay. So better be clear of how much space you want, how much space you are using. Okay. Fine. All right. So let's stop here. Let me take attendance. Yeah, I am taking attendance.